Hello students. Welcome to your school YouTube channel. Today's topic is, why does air friction affect a car's gas mileage? So without wasting time, let's quickly start the video and learn. When you drive a car, you're not just moving over the road, you're also pushing through the air. This resistance from the air, known as air friction or aerodynamic drag, plays a significant role in how much fuel your car consumes. Understanding this concept can help explain why driving at high speeds or in certain conditions can reduce your car's gas mileage. What is air friction? Air friction, or aerodynamic drag, is the resistance a vehicle encounters as it moves through the air. Although air seems light and invisible, it's made up of billions of tiny molecules. When your car moves, it has to push these molecules out of the way. This takes energy, which your engine provides by burning fuel. The faster you go, the more air molecules you hit per second and the more resistance you face. How air friction affects fuel consumption. A car's engine works to overcome several types of resistance: rolling resistance from the tires, mechanical resistance inside the engine, and air resistance at low speeds. Air resistance is relatively minor compared to other forces. However, as your speed increases, aerodynamic drag becomes the dominant factor. Here's why air resistance increases with the square of your speed. This means if you double your speed, the air resistance doesn't just double, it increases by 4 times. To push against that extra force, your engine must work much harder and burn more fuel. So, driving at 80 kilometers per hour is not just a little more fuel hungry than driving at 40 km/h. It can be much more inefficient due to exponential increases in drag. The role of car design. Car manufacturers are constantly trying to reduce air drag to improve gas mileage. They do this by designing vehicles with aerodynamic shapes. A sleek, curved car with smooth edges allows air to flow over it more easily, creating less drag. In contrast, boxy cars or vehicles with roof racks or open windows increase drag, making the engine work harder. Wind tunnels are often used to test car models. Engineers analyze how air flows around the body of the car and make design changes to reduce turbulent airflow, which contributes to drag. The smoother the airflow, the better the fuel economy. Driving habits and conditions matter. Your driving style also affects how air friction impacts your mileage. Highway speeds gas mileage typically drops significantly above 50 miles per hour, about 80 kilometers per hour, because of increased drag. Windows open versus AC. Driving with windows open can increase drag, especially at higher speeds. Ironically, using air conditioning may sometimes be more fuel efficient on highways. Roof racks. Adding a roof box or carrying bikes on top of your car increases frontal area and drag, decreasing fuel efficiency. Even windy weather can change things. Driving into a headwind increases air resistance and fuel use, while a tailwind can reduce drag and improve efficiency. Impact on electric vehicles. Air friction affects electric cars the same way it affects gas-powered ones. Higher drag means more energy is required to maintain speed, draining the battery faster. That's why improving aerodynamics is crucial in EV design, as range anxiety is a key concern for drivers. Conclusion. Air friction is an invisible but powerful force that directly affects your car's gas mileage. As speed increases, the drag increases dramatically, requiring more energy and thus more fuel to maintain motion. Vehicle design, driving habits, and environmental factors all contribute to how much air friction a car experiences. Understanding and managing these factors can help you drive more efficiently and save on fuel costs, whether you're driving a gasoline car or an electric one.